All right, it's 10 a.m. We are going to go ahead and get started here. Thank you all for joining us for our first AP Statistics Content Review session. We're joined today with Dr. Sherry McGuffin, as well as our presenter, Mr. Bob Lachelle. So we are looking forward to a great session. Bob is an experienced AP reader, AP stats teacher, so I'll let him tell you more about him later on. But I just wanted to go over a few housekeeping items here to begin with. So on the front screen there that you're looking at, you can see Bob's email if you need to get in contact with him, as well as the link to today's handout. So please make sure you have those. All right. So Advanced Kentucky, we are happy to host. Our Twitter, Facebook is right there, along with emails for myself. I'm the content director for mathematics, and Dr. McGuffin is our STEM coordinator. So please feel free to give us a follow or send us an email if you have any questions after this session. Your microphones are going to remain off for the duration of our session, so please utilize the chat feature. So please find that chat button at the bottom of your screen. You are able to chat with the general chat participants as a whole, and you can also send direct messages to myself, Sherry, or Bob. So if you don't feel comfortable asking everyone in the group, feel free to send us a private chat there. Your videos, please leave your videos off for the entire time. Please also check out our website, kyap2020.com. Hopefully that's how you found this session and the links, but there are plenty of other resources, especially if you are a student or teacher of AP Math, Science, English, Computer Science courses. Those sessions will also be going on. And finally, we would like to collect just a snapshot of data of who all is, oh, sorry.
Hey, Aaron, there's a few people in the chat saying they can't hear. Can you guys hear me?
I can hear you.
There's people in the chat saying they can't hear anyone. And you are unmuted.
If you go to the bottom left of your screen, or if it's on a phone, you have to initiate your audio to be able to hear. So there should be right where the microphone is. If you click on that, and you can enable your audio there, and that allows to enable. And I'll type that in the chat box as well, because it's for me.
There's a couple of you that have not joined via audio. So even though your microphones will be muted, you still do need to join in via your computer or microphone audio. All right, one final thing. So we do want to collect just a snapshot of who all is here. So I'm going to pause our recording here, give you the chance to open up your own web browser. If you can go to this bit.ly link here and please fill out, it's a very quick four question Google form. I would do that. So I'm going to pause our recording and then give you about 3 minutes here to make sure you got everything situated, make sure you can sign in to the Google link, and then we will resume. So I'm going to All right, we're back. I'm going to stop sharing my screen here, and I'm going to turn it over to Bob, who can introduce himself, and then we will get started. So thank you very much for joining in. Please use that chat room. Dr. McGuffin and I will be monitoring and asking questions if you have them.
Good morning, everybody. Hopefully you can see my PowerPoint screen right now. So give me a yell in the chat if that's what you see, as I get myself ready to go here. Thank you very much. So today is all about sampling distributions. So just a brief introduction. My name is Bob. I teach at Happer Horsham High School. It's just outside of Philadelphia. I've been teaching stat for, I think, 15 years now. Enough years where I have to really think about it before I can respond to that. It might be helpful if you have a calculator nearby. We are going to do some problems that involve calculations today. And I felt like a picture of me at a baseball stadium was appropriate today, because we're all looking forward to going back to wonderful things like baseball and summertime activities, and hopefully we can do that soon. So before we get started, so we now know the AP exam is on Friday, May 22nd. If you could in the chat, who are you? Where are you from? Are you a teacher or a student? And what one word describes your feeling about this year's AP Stat exam, which is now just 44 days away? So let's take about 30 seconds. If you could give a quick introduction so we know who we have here. Ms. Gleason's very anxious, thank you. And throughout this hour, we'll be looking at the chat, and Sherry will be looking at the chat and hopefully telling me about the questions that I'm missing. Very anxious, yes, it's a whole new world for all of us. Concerned, yes. Unsure.
Looks like I saw one optimistic there too, Bob.
Oh, thank you. Yeah, Forrest is optimistic. Yeah, unknown, waiting, stressed. Don't be stressed. Don't be stressed. So I'll give you the same, for the students I see here, I will give you the same advice that I give to my students. Exams like the AP exam are not designed to ding you on things you don't know. They are intended to let you shine on the things you do know. So think about the things that you do know and that you really know well and do well with those pieces. So today we're going to talk about sampling distributions and give you some review, talk about big ideas, and I'll also incorporate some ideas for what I think they might ask you about sampling distributions on this year's exam. So we're going to start off right away with a review question. This one's about rainbow trout. Here we have the lengths of 6-year-old rainbow trout have an approximately normal distribution with a mean of 48 centimeters and a standard deviation of 4 centimeters. What is the probability that a single captured trout has a length less than 47 centimeters? If you could, and I don't want to dwell on this particular question too long, can you generate an answer using whatever means you have there? Let's say 30 seconds for that. Thank you to all my first-year teachers. I find that AP Stat is a much different experience than teaching something like algebra or geometry. So hopefully you see on the screen here, this is a problem that many students would define as a norm CDF question. If you're using a TI-84, it is a normal distribution question. So if we let X equal the length of trout, we should define that X has an approximately normal distribution with a mean of 48, standard deviation of 4. You could also write those variables out as mu sub X and standard and sigma of X. And at that point, we want to define the probability statement. You don't have to include z-score. And then a nice picture always does the trick in terms of showing us the probability, which is 0.4013. So that, again, is what we would normally call a normal distribution calculation. But let's think of a slightly different question here. Same scenario about the rainbow trout, but this time a random sample of 10 trout are captured from a lake. What is the probability the captured trout have a mean length less than 47 centimeters? This time we're capturing 10 trout. We want to take their mean. This means think about a random sample of 10 trout. We might get some long trout and some short trout, some medium-sized trout, trout from all over the spectrum. What's the probability their mean will be less than 47? And this is the big deal here that we need to think about today. We're talking about individual observations versus a random sample. And when we take a random sample of things and we look at their mean or we look at their sample proportion, we're talking about a sample distribution. So here are the big ideas. For a sampling distribution of a sample mean, the big ideas you have to think about are center, shape, and spread. Anytime we're asked to describe a distribution, we want to think about center, shape, and spread. For a sample mean, that means we're going to encounter 3 things. The center, if we sample randomly from a large population, sample means will cluster about the true mean. That's the idea of an unbiased estimator, that random samples should cluster around the truth. Symbolically, that means the mean of X bar is equal to the true population mean, which we know is mu. Shape, the shape of a sampling distribution of sample means will be approximately normal if, and there's actually 2 ways this can go here, and oftentimes people forget the first one. If the underlying population is approximately normal, the sampling distribution will also be approximately normal. Now that's often wishful thinking, or sometimes we use things like box plots to try to tell us that down the road when we do hypothesis tests. Or the main idea here is that if the sample size is large, greater than 30, we have this wonderful thing called the central limit theorem, which kicks in and tells us the sampling distribution will be approximately normal. And I tell my students that the central limit theorem is really the heartbeat of much of what we do in statistics. That samples, if we do them correctly, we randomly sample, they should cluster around the truth and be approximately normal. And the spread, in general, as sample size gets larger, the sample means will cluster more about the true mean. And we do have a formula for this. That sigma of X bar, the standard deviation of the sampling distribution, will be the population standard deviation divided by root n. So now let's apply this to the problem we have here. So we have this lengths of 6-year-old rainbow trout. And if you take a look at the graph here, the population distribution is in red. It has a mean of 48 and a standard deviation of 4. But the sampling distribution, if we take sample sizes of size 10, they will cluster more about the mean. And what you should see visually here is that the area underneath the red curve is larger. There's more area than underneath the blue curve because we're clustering more amount around the true mean. So this is a nice visual that hopefully tells you the difference between a population distribution and a sampling distribution. So let's answer the question we had before. A random sample of 10 trout are captured. What is the probability they'll have a length less than 47? We have a center around 48. Let me get my laser pointer here. The mean will center around 48. The shape will be approximately normal because the underlying distribution of fish is approximately normal. We will use the standard deviation formula here, 4 over root 10. We find the decimal version of that. We have an approximately normal distribution of the sample means, and then we can find the probability, and always a nice picture helps out with the cause. Okay. So let's do a stop and think here. So let's change this question slightly. How would the probability we just found of finding a sample mean less than 47 centimeters change if we captured 30 fish rather than 10 fish? How do you think that probability might be different? So I'm going to pause for about 30 seconds. Feel free to use the chat to give your ideas, especially with our students in the audience. How do you think the probability might change? And sometimes with the chat, we get these awkward silences too. So I'll prompt you a little bit more here. How might the probability change? Do you think the probability be larger or smaller or maybe equal? We have one vote for decrease. Another vote for smaller. Well, one thing that's helpful to do here is to draw a picture of the situation. So if we look here, we have, let me get my pen out here. The blue represents the samples we just took of samples of size 10. But now we're going to take samples of size 30 and notice what happens is that curve gets more condensed, becomes less variable, clusters more around 48. So if we look at 47 here and I find this shaded area, you should see that that area for the orange curve is smaller than that of the blue curve. So one of the big ideas that we want to talk about here is that as sample size increase, the idea of an unusual result decreases. And keep in mind on this year's AP exam, there are rumblings out there that this will be, although you're allowed to have a calculator, most of the problems you're going to see can be done without a calculator or just with a scientific calculator. So this might lead us to believe that we're going to speak more in big ideas than in calculations, being able to speak in big ideas. And we'll see some examples in that in some of the past AP problems we're going to do here. Okay, any questions up till now? We're going to move on to proportions in a moment. Sherry, I don't think I saw any questions in the chat there.
And I'll chime in. You know, we have a lot of teachers joining us, so teachers, feel free to ask your questions from a teacher perspective as well. I know that this is geared towards students, but we are happily ready to entertain your questions as well.
Awesome. Thanks, Aaron. And I'll keep looking at the chat for questions as we go along. Let's think about, oh, go ahead, Sherry, go ahead.
Oh, that's okay. Sorry, I was just including a couple different just notes on things as you were making comments, because we had some new people that entered.
Fantastic, thank you. Let's take a look at proportions as well here. Here's a problem about an educated workforce. Approximately 30% of the US adult population has a bachelor's degree. A random sample of 250 adults includes 82 with bachelor's degrees. Should we be worried that our sample has overrepresented degree holders? So we take a look at some of the salient ideas here. 30% has a bachelor's degree. We have a random sample in which 32.8% have bachelor's degrees. And the idea is that an unusual result? How likely is it that we would see a result that extreme? What I want to focus in on here is using correct symbols. Now that we're looking at samples and we're taking a proportion of something, we're talking about p-hats here. So using correct symbols to indicate what we're communicating is going to be one of the big ideas we want to focus in on. So for sample proportions, let's think about the sampling distribution of a sample proportion. Again, we want to look at center, shape, and spread and make sure we're clear on those three big ideas. And center, if we sample randomly from a large population, sample proportions will cluster around the true population. We'll have an unbiased estimator. That means that the mean of repeated p-hats will center around the true proportion. Make sure we're clear on the symbols here. Repeated p-hats, if we took all possible p-hats, they should cluster around the true proportion. Shape, the shape of the sampling distribution will be approximately normal if the expected number of successes and failures are both greater than 10. This is a rule you know not just hopefully from sampling distributions, but also as you've done your hypothesis testing when we think about proportions, where we always want our expected number of successes and failures to be greater than 10, or the actual number of successes and failures if we're talking about a confidence interval. And the formulas there are NP greater than 10, and then 1 minus P greater than or equal to 10. So as you've gone through your stats units, hopefully this is something that's become more familiar to you. And the spread, in general, as sample size gets larger, the sample proportion is more likely to be close to the true population proportion, and we do have a formula for that. And we're going to talk about how we don't need to memorize that one. That's one that is given to us on the AP exam. So let's apply this to the problem we have here. Should we be worried that our sample has overrepresented degree holders? Center, shape, and spread. The center, the mean of repeated p-hat should center around 0.3. Shape, the expected number of successes and failures, both greater than or equal to 10. So we have an approximately normal sampling distribution. And the spread, we can use the standard deviation formula to see 0.0299. That is our spread here. We can apply that to the problem, draw a picture, and we see that 0.1670. It does not seem like getting 32.8% people with bachelor's degrees is really all that unusual result because it's 0.1670. Now, you should be familiar with the center, shape, and spread for sampling distributions for sample proportions, but I'll be honest, we're not going to do many problems with that because you may also identify this problem as a binomial problem. This is one that could be done using a binomial approach, and that would be totally okay. However, the reason I'm bringing this up is notice how many of these ideas, like, let me get my pen out here, the shape, come back to us again when we talk about hypothesis testing and approximate normality. Okay, so we're not going to do many proportions problems, but notice how the ideas are used in later chapters. Okay, and you don't have to stress over memorizing formulas. This is the formula sheet for the AP Stat exam. These things are given to us here, but what I want you to think about in terms of test tips, the big ideas here are be able to identify when a problem references a sampling distribution. And I'm going to show you some examples where maybe that idea is hidden, and use correct symbols to identify center, shape, and spread. I know with my students, oftentimes students just want to show a calculation or just want to show a formula, but putting on these symbols, for example, identifying to me that we're talking about the sampling distribution of p hat. That symbol is a big deal because it clearly identifies what it is you're talking about. So using those symbols is a big idea. So before we dive into some past AP problems, I'm going to pause again for any questions in the chat. At this point, for the next about half hour or so, we are going to look at some past AP problems that deal with sampling distributions. Aaron, I'll let you take that first question there if you want to dive in. Oh, there you go. Thanks, Aaron. Okay, so keep the questions coming. If there's any in the chat, that's fine. So let's dive into our first question here. This is a question from 2009. We have a tire manufacturer designed a new tread pattern for its all-weather tires. Repeated tests were conducted on cars of approximately the same weight traveling at 60 miles per hour. The tests showed that the new tread pattern enables the cars to stop completely in an average distance of 125 feet with a standard deviation of 6.5 feet, and that the stopping distances are approximately normally distributed. What I would like you to do, and let's take about 60 to 90 seconds for that, read all three parts A, B, and C. And I don't want you to do the question. I don't want you to find an answer, but what I want you to think about is where in the stat curriculum have you seen these questions? What type of question is it? What's the big idea? Maybe what is it you would do in your calculator? So can you identify what type of questions we have for parts A, B, and C? And if you're bold and brave and you feel like putting those in the chat, that's great. Otherwise, we'll just talk about them here. So let's say 60 seconds to look at all three parts. feel like I should have brought some Jeopardy music along. That's okay. Okay, especially for my students out there, for part A, how would you categorize that question? What type of question is that? What is going on in part A? What is the 70th percentile of the distribution of stopping distances? And this is like my class too with the awkward silences. So if not, we'll just reveal and we'll see if people will watch the video later. Oh, that's quite all right, Trish. Oh, 7 a.m. Well, I appreciate you being here at 7 a.m., Trish. Well, part A, we're looking for the 70th percentile. If you draw a good picture here, you might recognize that that is an inverse normal problem. In kid language, in TI-85 world, that's inverse norm. You draw a good picture, enter the information, and know that that's an inverse norm. How about part B? What is the probability that at least 2 cars out of 5 randomly selected cars in the study will stop at a distance that is greater than the distance calculated in part A? What type of question is part B? Being able to categorize these guys and read and identify is part of the survival for us in AP Stat. Well, we're looking for probability, at least 2 out of 5, and we have a probability given to us up there. That will be I click over here, a binomial distribution problem. That'll actually end up being a binom CDF for those of you in TI-84 world. But part C is really the one we want to focus in on, because part C is our sampling distribution problem. We have a randomly selected sample of 5 cars in the study. What is the probability that will mean stopping distance of at least 130 feet? Okay, so let's take a look at this question here. And actually, let's go through the answer key for this question. Let X bar denote the mean stopping distance. All the tires have the new tread pattern because the stopping distance for each of the 5 cars is a normal distribution. The distribution of X bar is normal with a mean of 125 and a standard deviation. The formula has been done here. And then we have a line here where the probability has been computed. Students often ask me, do I need to put in the Z-score formulas? The answer is no. If you just use your calculator, if you just go from here to here, that's fantastic. However, showing the Z-score does show some statistical understanding that could help you, especially if between grades. But I also want to go through the key on this one. The key on this one says that there are 3 things you need to do, and this is where you need to be very specific. We need sampling distribution, meaning that when you talk about this problem, make it clear that you're talking about the sampling distribution of X bar. So I would actually prefer that students, and I'm going to try to write on the screen here, it's going to get messy, that we call this guy.
And Bob, when you get a chance, we had someone ask if you could go back to the previous slide for just a few seconds. I think they missed some information.
Sure, I sure will. So I would call this mu of X bar equals 125. That would indicate that you're talking about a sampling distribution of a sample mean. And I would call this guy sigma of X bar. And if you do that, it makes it clear that you're talking about a sampling distribution of a sample mean. We also have the parameters, which means actually tell what the mean and standard deviation are, and then have a correct calculation. So 3 things you need to do. Yeah, so let's go back to that previous screen so people can take a peek if they need to. Let's undo my pen. And this is for Charlotte. Charlotte, are there any questions? And let me know when you're good with that one there. And these are also posted. I know that the resources are posted on Advanced Kentucky's website as well. And this will be recorded. Thanks, Charlotte. Okay, there's all my right on stuff. But let me ask a follow-up question here. Here's my follow-up. This part was not part of the AP exam. Let's say those who designed this study would like to redo part C such that the standard deviation of the sampling distribution is multiplied by 1/2. How many cars would need to be randomly sampled? So we want that the standard deviation of the sampling distribution to be cut in half, for lack of a better phrase, multiplied by 1/2. Would you need more cars? Would you need less cars? And can you find out how many cars would you need? Pause for about 30 seconds to let you think about that one. And if there's other related questions, you can ask them in the chat. if you would like to show off in the chat, I'll even throw it out there for the teachers too, because this one was not part of the AP exam. If you have an answer you would like to share, feel free. Let's take a peek here. And the answer is, I'm just going to flat out give you the answer first, is 20 cars. So let's take a look as to why here. Why is it 20 cars? So here's the mathematics behind it. Let me walk you through here. So we have our standard deviation of our sampling distribution, and we want it to be 1/2 multiplied by 1/2. So there's a little algebra going on here. 1/2 we know is the same as square root of 1/4. And we know these two guys now can be multiplied by each other, and we end up with this expression. And the big idea here, and this might be helpful if I change colors, is that we've gone from a sample size of n to a sample size of 4n. We would need to quadruple our sample size. So if we had a sample size of 5 cars before, in order to multiply the standard deviation by 1/2, we would need a sample size of 20 cars. But there's a big idea lurking in there, and the big idea is that multiplying sample size by 4 multiplies the standard deviation of the sampling distribution by 1/2. Okay. Multiplying the sample size by 9 would also multiply the sampling distribution by 1/3. Okay, so big idea there. Bigger sample size means that you are getting less variability in your sampling distribution. Okay, we're going to see an example of that in the next free response question we're about to do. Okay, here's our next challenge. This one's from the year 2014. This one is about school funding. Schools in a certain state receive funding based on the number of students who attend the school. To determine the number of students who attend the school, one school day is selected at random, and the number of students in attendance that day is counted and used for funding purposes. The daily number of absences at high school A in the state is approximately normal, with a mean of 120, standard deviation of 10.5. So part A is if more than 140 students are absent on the day of the attendance count, I misread that, or absent on the day the attendance count is taken for funding purposes, the school will lose some of its state funding in the subsequent year. Approximately what is the probability that high school A will lose some of this funding? So this one, I'm just going to flat out give you the answer to. You should identify that this question is just one of our norm CDF type questions. You can simply plug it into your calculator. You're given a normal distribution with a mean and a standard deviation. I want the probability X is greater than 140. The answer to part A is 0.0287, and you're welcome to go back and verify that using technology. But the one I really want to focus in on is part B. Part B, the Principals Association in the state suggests that instead of choosing one day at random, the state should choose 3 days at random. With the suggested plan, high school A would lose some of its state funding in the subsequent year if the mean number of students absent for the 3 days is greater than 140. Would high school A be more likely, less likely, or equally likely to lose funding using the suggested plan compared to what happened in part A? And then you have to, of course, justify your choice. So a couple things about part A. There's some keywords in here that we want to look at. We are talking about choosing 3 days now at random, not just one day. And we want the mean number of students absent. So those big ideas are lurking in this question. This really is a sampling distribution problem where we're looking at 3 days. We're going to average the number of students absent, and we want to know about the mean number of students absent. High school A be more likely, less likely, or equally likely. So again, let's take about 60 seconds to think about, do you think the answer is more likely, less likely, or equally likely? If you have an answer and maybe a brief justification you want to give in chat, what do you think we need to say here? You're welcome to do that. Or if you have questions in other regards about this question. But let's say 60 seconds on this one. Thank you, Ashton, for your response. I don't know if Ashton is a student or a teacher. I'm not sure. Less likely, the probability would move closer to the true mean. we're going to talk about that answer, but thank you for participating. Ms. Gleason, so my understanding is that the reference sheet will not be a link during the test, but students should have it with whatever notes that they're using. So printing it out for my students use OneNote. So I'm going to give them the PDF to look at on their computers during the exam. But I believe I saw somewhere that the formula sheet will not be there, although I can't confirm that that's totally true. I would have it ready for the students. You're welcome. So Ashton thinks less likely. Okay, so I want to look at this one two ways. This is a question that can be answered in two different ways, and they're both interesting in their own way. So let's look at both of them, and they're not meant to be done all together. So for example, let's look at this one. This would be a complete response. High school A would be less likely to lose state funding. Nice job, Ashton and Asa. With a random sample of 3 days, the distribution of the sample mean number of students absent would have less variability than that of a single day. With less variability, the distribution of the sample mean would concentrate more narrowly around the mean of 120 students, resulting in a smaller probability that the mean number of students would exceed 240, or 140 rather. So notice in this one in blue, this is a complete response that doesn't have any mathematics in it. By mathematics, I mean computations. It's all just statistical argumentation. As long as you talk about understanding that the sampling distribution will be less variable, it's more likely to concentrate around the 140, making the probability of 140 less likely. I would think here also drawing a picture would be very helpful. If you draw a picture like the ones you saw in some of the previous screens, that would be much more helpful. But you could go the route of actually doing the work here because you were given enough information to do that. You could find the probability it's given here is 0.005, and then you simply compare one to the other. And what I want to focus in on here is anytime that we look at AP problems, there are always comments from the chief reader. So these were some comments from the chief reader this particular year. And what I want to focus in on here is many students did not make it clear that the distribution of the sample mean was relevant. Just saying the mean would do this or the standard deviation would do this would not be enough. Make it clear that you're talking about the variability of the sample means, that somehow we're taking random samples and we're talking about the X bars clustering more around mu. So some way to make it clear that you're talking about those things. So my big piece of advice for you in this type of question is use appropriate symbols again to communicate ideas, that we're talking about mu of X bar and sigma of X bar. And if you use those symbols correctly, those are replacements for having to write out the sampling distribution of the sample mean. So being proficient with the symbols communicate true statistical ideas. Okay. Any more questions? We have 2 more questions left, but I think we'll probably just get to one more in deep detail. So any more questions about sampling distributions up to this point? Any misconceptions we can talk about? Fantastic. Okay, we're going to look at one last question as a part A, B, and C. And I will tell you that as someone who's trying to train my own students for the AP exam, I think this question is a wonderful example of a type of argumentative question that you could see on the AP exam that does not require a calculator and deals with sampling distributions. So let's take a look at it. This is from 2007. Big Town Fisheries recently stocked a new lake in a city park with 2,000 fish of various sizes. The distribution of these fish is approximately normal. So we're going to look at all 3 parts here. So here's part A. Big Town Fisheries claims that the mean length of the fish is 8 inches. If the claim is true, which of the following would be more likely? A random sample of 15 fish having mean length greater than 10 inches, or a random sample of 50 fish having a mean length greater than 10 inches. And I will tell you what I like about this question. First of all, you have to make a choice, and you have not been given enough information in this problem to do anything in your calculator. You need to provide a statistical argument. So take a moment, think about which one you would answer. And if you'd like to share a justification within the chat, I'd appreciate that. Again, another, let's say 60 seconds on this one. I really appreciate the people who are giving their answers in the chat here. First of all, we've given an answer of 15 fish. Things like the standard deviation becomes smaller, and 15 fish because the standard deviation is larger. And Clinton says more prone to variability. Okay, so let's take a look at how we could approach this question. What I would suggest you do in this question is you draw it. So I have two graphs here, a green and a red. One of them represents the sampling distribution when n equals 15. One of them represents the distribution when n equals 50. My challenge to you is, can you tell me which one is which? Let's say, which one is the n equals 15? The red or the green? Red, red, a lot of reds. Thank you all. Petty's in there. Charlotte's in there. We have some new people in there. Fantastic. Yeah, the red is the 15. So let's take a look at the model solution and see how this picture helps us support that. The random sample of n equals 15 fish is more likely to have a sample mean length greater than 10 inches. The sampling distribution of the sample mean x bar is normal. They give us the mean, and we have a standard deviation here that we can't fill out. Both sampling distributions will be centered at 8 inches, but the sampling distribution of the sample mean when n equals 15 will have more variability, and the tail area will be larger. So I would say in this picture, first of all, we have n equals 15 and n equals 50. If you drew a picture like this, now it doesn't have the numbers on the bottom, and in fact, we don't know the 6 and the 10, but we know it's centered around 8, and we want to find the probability that we are greater than 10. Let me get my pen out. Oops, didn't want that. Let's get the pen out. If I draw where 10 is, I can see clearly, wow, that's not a great line, but you get it, that the red area is much bigger than the green area, the area underneath the red curve. So therefore, the probability of getting a random sample that extreme when n equals 15 is more likely than n equals 50. So I think drawing a picture like this to support the variability argument would help you along here. And along with that, that part is scored essentially correct. If the student says it's a sample of 15 fish, is more likely to have a mean length greater than 10, and the justification has to be based on the variability and make it clear that we're talking about a sampling distribution of the sample mean. So using that phrase, the sampling distribution of the sample mean, to make it clear that you know what you're talking about is going to be big here. Any comments, questions about that one? Notice we didn't need a calculator for that one, and a statistical argument was made. I would think this would be a type of question that would be fair game on this year's AP exam in terms of argument. Okay, let's move on to part B. We're going to do all three parts here. All right, part B. Suppose the standard deviation of the sampling distribution of the sample mean for random samples of size 50 is 0.3 inches. If the mean length of the fish is 8 inches, use the normal distribution to compute the probability that a random sample of 50 fish will have a mean length less than 7.5 inches. Okay, because of time on this one, and also this one is a computation problem, which again, we don't suspect this type would be on the AP exam, although we're not sure. But what I want to point out here on this one is, notice this 0.3, whoops, let me go forward, get my pen out here. I want to highlight this 0.3 number. You need to be clear on what this 0.3 represents. We're told that the standard deviation of the sampling distribution is 0.3. So that number is sigma of x bar. That number has already been divided by root 50. So there's no need to divide it by root 50. It's already been divided. Okay. So if I take a look at the work here, this is one you can just do as norm CDF. You've been given a mean and the standard deviation. Plug into your calculator, get 0.0475. And again, the question often being from kids, do I have to show z-score formulas? The answer is generally no. It helps support your work. This is one you easily could do that because I have 7.5, 8 is the mean, and my standard deviation is 0.3. So part B is a traditional norm CDF problem. Okay, well, let's get to part C, because part C to me is very interesting. Suppose the distribution of fish lengths in this lake was non-normal. So we're going to rip apart the approximately normal part. We're going to take this part about approximately normal, and we are going to say, hey, let's get that out of there. We do not know the distribution of the lengths of the fish approximately. All gone. Would it still be appropriate to use the normal distribution to compute the probability in part B and justify your answer? Again, this is a non-calculator question. So let's take another good 60 seconds. We can have some, especially students, participate in the chat. What are your thoughts about C? And thank you to, I hope I'm saying your name right, Asha. She says, yes, because CLT and N is greater than 30. This is a question for my students, man. You just want to grab as many points as you can on the AP Stat exam. And this is one, if you understand big ideas, this is a question where not only are you going to grab points, you're going to grab points in a pretty easy way here because there's not much to do. There's no calculation to do. It's just either you understand the big idea and you're going to knock it out of the park, or frankly, you're going to write a bunch of gibberish probably. So let's take a look at this one. Yeah, and Ashton agrees here, and that is a correct answer here. Yes, the central limit theorem says the sampling distribution of the sample mean will become approximately normal as the sample size increases. And we have a sample size of 50 that is larger than the agreed 230. Therefore, we have an approximately normal sampling distribution. Yeah, this is one, if you just said 15 is greater than 30, the central limit theorem applies, you're pretty much good to go in part 3. And notice how quick and easy part C can be if you understand the big ideas here. That as sample size gets bigger, sampling distributions will become approximately normal. Okay. Okay, we have one last question to do today. It's only going to take us a few minutes, so I'll pause for any other general questions in the chat. Sherry, I don't know if you've seen anything or you have anything to add on this one before we go to the last question.
No, I haven't seen anything, but real quick question about context and how important
Oh, yes.
is.
Yeah, fantastic point. Yeah, what is it the sampling distribution of? It's a sampling distribution of the sample means of, I forget what this one's about. The fish lengths. Yes, context is very big. Always writing in context here. It's amazing how often we see students, and I think that particularly this year, and again, we don't know how this year is going to look, but I think this year when we know that students will have notes, we know that students will be able to look back on materials, make sure not only that you're talking in big ideas, but using those big ideas to talk about the problem you have in front of you. So if the problem is about fish, make sure you're talking about the distribution of fish lengths. Okay. The earlier question, we talk about the number of days of students being absent on a particular day, making sure that you're tying the big idea to the context you have in front of you. Thank you very much for that suggestion. Okay, here's the last one. We're not going to spend a lot of time on the last one, and this I noticed it's tough to see on the screen, but hopefully you downloaded the handout. This is a question 6 from a previous year. If you haven't done a whole lot of question 6s, they're often called the investigative task. Every year up until now on the AP exam, there's been an investigative task that often has multiple parts tied around one context. To be frank, they can be somewhat intimidating. This one from 2015 was about tortillas on a production line. I invite you to look at it because it is a great problem about sampling and looking at different ways to sample and where things center and what's going on here. So we have part A and then part B and then part C. What I want to focus in on is I've given this problem to my students before, and often they will look at A, B, and C. They get tied into these graphs. They start talking about these curves. And then all of a sudden we see this in part D. Describe the sampling distribution. And we need to think about this because we always need to be anchored to, okay, what does that mean? Describe the sampling distribution. And the big idea course-wide is anytime you're asked to describe a distribution, hopefully you're talking about center, shape, and spread. Some of you might know this as CUS within what you do within your AP exam for center, shape, and spread. Some teachers call it SOX. I don't know what other agreed to acronyms there are out there. I use center, shape, and spread. So when it says describe a sampling distribution, I look at part D as, hey, wait a minute, this is a question where all I need to do is give a list in context of the center, shape, and spread. So this will be the last one we do. Can you take about 30 to 60 seconds and think about how would you describe the center, shape, and spread of the sampling distribution of the mean diameter for the samples here? Okay, let's take a look at the model solution for this one. Okay, center, shape, and spread. This is a mean tortilla diameter. This one was all about tortillas. The sampling distribution of the sample mean diameter will be approximately normal. Let me highlight where these things are being shown here. Approximately normal. Now, one thing, this is a question 6 from this particular year, and oftentimes in question 6s, we're a little bit more lenient on what kids write. I would ask my students to tell me, how do you know it's approximately normal? I don't recall if earlier in the question we were told that tortillas are approximately normal, but I do know that I have sample sizes of size 200. So if there's sample size of size 200, I know that the samples are sufficiently large. The central limit theorem will kick in, approximately normal. A mean of 6 inches, hopefully you're labeling that as mu sub x bar, because that would take care of the sampling distribution of the sample mean and the standard deviation of the sample mean, sigma of x bar, and we use the formula for that. So center, shape, and spread. And again, using this symbol with this result takes care of the first sentence. It means that you're talking about a sampling distribution of the sample mean diameter. And here's the standard deviation of the sampling distribution of the sample mean diameter. So you can write out all these words if you like, but the symbols communicate things and statistical ideas. So hopefully you have the center, shape, and spread there. So that is the end of what I have for this hour. There's my information again. I'll put that there at the end. Are there any other final questions, things that people are worried about, other things I can address? But otherwise, Aaron, I'm going to hand the ball back to you, and we are pretty much done with the content for today. Thank you very much.
Thanks, Bob. Great job. We learned a lot. I certainly found it very informative. So I'm guessing that hopefully the other teachers and students in here did as well. I'm going to share one other screen with you all, just to recap. So again, Advanced Kentucky, our website is advancedky.com. Find us on Twitter, Facebook. You've got contact information for myself, Dr. McGuffin, and Bob all right there. Give Bob a follow on Twitter. He's got some great resources on his own personal website as well. Handouts to today's sessions can be found at kyap2020.com or by following the bit.ly link. If you've not had the chance to sign in because you joined late and you missed that, please sign in so that we can keep track of how many people are attending these sessions. This will be recorded and posted to the KYAP 2020 website here upon the conclusion of the session, as long as it takes the video to process. Next week, we will be joined by Reva Sloan. She is an AP exam reader from Kentucky here, and she will be covering Unit 6, which is inference, specifically focusing on proportion. So that should be really good as well. So please join us. Tell your friends, tell your teachers, tell your students. Please participate in these. We look forward to hosting them. We feel they can be very supportive to what AP is doing with the College Board YouTube videos. And we look forward to seeing you all next week. So thanks, Bob. Thanks, Sherry. You all don't have any other closing words. We will go ahead and end the recording.
No, fantastic. Just there's a lot of resources out there for this new AP exam. Just keep looking for them. And the College Board YouTube also has a lot of videos they're going to be doing. So there's a lot of great stuff out there, and make use of those materials.
All right. Thank you all so much. We will see you here next week, same time.